All right, so today we're going to talk about z-scores, but before we do that, let's just review a little bit about this standard curve and what all these percentages mean. So on your homework last night, you would have gotten something like this. It would have said the mean set of data is 80 with a standard deviation of 4. So remember, this middle here is where your mean would be. So that would be 80, and each one of these lines is a standard deviation. So this next line, which is one standard deviation above the mean, would be 84. So if you got an 84, you would be one standard deviation above the mean. That's showing you where you are on this chart. Now, if I wanted to know what is the percentage of people you did better than, then you would take all of this percentage, this 34.1, 34.1, 13.6, 2.2, and 0.1, and you would add them all up, and that would tell you how many people you did better than. So you did better than 84.1%. So again, this is just adding up all of these percentages. If I said you got an 88, then you would be here, you'd be 2 standard deviations above. Well, because you're right on this line, it's really easy. You just add up all those percentages, and you would find out that you're 97.7%. So you did better than 97.7% of the people in your class. If you got a 76, you would be one standard deviation below, so you'd be over here. But again, because you're nice on this line, you can just add up these percentages, and you would know that it would be 15.9%. But what if you got an 82? Now you're no longer right on one of the standard deviations. But this would be like 0.5 standard deviations above the mean. So that wouldn't be too hard to figure out, because I could take this 34.1 divided by 2 and then add up all the rest on this side here of the curve. And that would still tell me what I needed to know. And that would be 67.05%. And then if they said, well, what about if you got a 90? Well, now that would be kind of up here. Again, that's perfectly in between 2 and 3 because the standard deviations are 4 units apart. So I could say, well, that's going to be 2.5 standard deviations away. And so I could take this bar here, this 2.2% divided by 2, and then add up all the ones to the left. And I could figure that out pretty easily. But it gets trickier if I said, well, what is 93? So now you're not completely in half. Or if I said, what if you got a 94.2 or something weird? Now it gets a little harder to figure out all the percentages. So they have this thing called the z-score table, which actually figures all these percentages out for you. In order to find what your z-score is, in order to read the chart, you have to fill out this formula. And the z-score will tell you the number of standard deviations that a score is away from the mean. So again, when on last night's homework, it was pretty simple because you were either 1 standard deviation away or 2 or 3, kind of a nice whole number. But if you were 2.17 away from the mean, it would be much harder to figure out what that percentage is. So the z-score chart will do that for you. In order to find your z-score, you're going to take whatever score you have. So like, for instance, the 93. You're going to subtract the mean, which was 80, if I remember right. And then you're going to divide that by your standard deviation, which in this case was 4. So this here's what the formula is. This is the formula that you'll need to know and to write down. This is what you will be using every time you use your z-score table. So this is what the z-score table looks like. There is a copy on Google Classroom. I would suggest you print it because it would be convenient to have it in front of you. But what this tells you, this z-score, all the way these are all the way down along here on the left side, will tell you how many standard deviations away from the mean you are. In the body of the table, all of these numbers give you the percentages. So wherever you are on this curve, it's always going to give you the percentages below that. So it's always going to give you this grayed out area. You're always going to do your z-score in 2 decimal places because if it told you that you were I'll go on this side. If it told you you were 1.15 away from the mean, you would look at 1.1 on this side, but then across the top, you'd look for the 0.05. And I'll show you that in just a second, a little bit bigger, where it's easier to read the chart. So first, let's just practice looking up the z-scores. So if I told you you had an average of 55 and a standard deviation of 3.4, and I said your x was 62, let's just practice finding the z-score. So the first thing you're going to do is just put all the information into this formula. So your x is 62. You're going to subtract the average, which is 55, and divide it by 3.4. So that'll tell you you are 2.06 standard deviations away from your mean. So again, if you were just using the chart that we had on your homework last night, it would be very difficult to kind of figure out what that percentage is. But you can just look it up on the chart and it will tell you. So you can go ahead and stop this video and make sure that you get these z-scores for these x values. The types of questions that I'll be asking will be, what percentage of the scores are below? So that's asking you, what is the left side of the curve? What percentage of the scores are above? So that's going to be asking you for the right side of the curve. What percentage scores are between? So then you're going to find two scores and you're going to find the percentage and subtract them. And if I chose a person at random, what is the probability that their score is whatever I ask? So remember, the percentages that you are finding in the body of your z-table are nothing more than probabilities. So the table gives you the percent and the probabilities that are below a given score. That's really important to remember that it's always giving you the less than side of the curve. So let's just say if you wanted to find a percent below a particular z-score. So let's see how we would do this on the chart. So if you were given a z-score of 1.28, which means you are 1.28 standard deviations above the mean, you would go to your chart. You'd go to the positive chart side of the chart because this is a positive number. You're going to scroll down on the left-hand side until you see 1.2. So you're always going to go to the first decimal place on the left-hand side, 1.2. Then you're going to go across the top to find your next decimal place, which is 0.08. Where those two meet is going to give you your percentage, 0.8997. What this tells you is that 89.97% of your data is going to be below 1.28 above the mean. So if you kind of think about what that might look like on your chart, right? If you had a curve here, and I can't draw it very well, but we'll try this. Right, there's your curve. If this is here is your mean, that's going to be whatever your mean was that they had given you. And you're 1.28 above the mean. So like if this is one standard deviation, this is two standard deviations, you're going to be right around here somewhere, 1.25. And so this tells you that this here, all of this here is 89.97%. So it's giving you the percentage below that particular standard deviation. And if you want to go ahead and find these others to see that you're doing it correctly, you can go ahead and do that. If you wanted to find the percentage above, the chart does not specifically give you that. So the first thing you would do is, if it says find the percentage above the 1.85, the first thing you do is you go to your chart and you look up 1.85. And you're going to see it's going to correspond to 0.9678. But remember what that tells you. That's going to tell you this side of the curve. It's going to give you the less than side of the curve. But you want to know is the greater than side. You want to know this yellow side of the curve. But the whole curve has to equal 100% or close enough. So you're just going to take 1 minus the 0.9678, and that'll give you this yellow side of the curve. or 3.22% will be above the 1.85. Same thing's going to happen if you're on the negative side. You're still going to do the same thing. You'll look up your z-score, you'll subtract it from 1, and you'll get your percentage. So you can go ahead and look that one up and make sure you get this answer. If you wanted to find the percentage between, you're going to look up your 2 z-score. So this is going to find out what would be between. So for instance, if let me try to draw this a little bit. It's going to say, like, if I had some sort of a z-score like this, and there's my mean, and it wants to know I'm at like 1.85, so this would be 1 standard deviation, this would be 2 standard deviations. So I'm going to be like 1.85 might be here somewhere. And 0.27 would be maybe like a little bit like here, a little bit above. So it's like saying finding what's in between. So how many are going to be in this blue area, if you will? That's kind of what this question is asking you. So what you would do is you're going to go to your z table or your z-score table, and you're going to look up both of these percentages. So if I look up 1.85, I'm going to get 0.9678. If I look up 0.27, I'm going to get 0.6064. I'm going to subtract the percentages. Make sure you always subtract the percentages. Don't subtract the x values. Don't subtract the z-scores. Always subtract the percentages. And that'll tell you that 36.14% will be between those 2 z-scores. This is what a typical question will look like. Boxes of cereal are filled by machine. Tests of the machine's accuracy show the amount of cereal in each box is normally distributed with a mean of 20 ounces and a standard deviation of 0.25 ounces. That normally distributed tells you that it follows the standard curve and kind of clues you in that you can use your z-score table. It gives you the mean, which is 20, and the standard deviation of 0.25. So the first thing I would do is write down everything I know. And it asks what percent of the boxes should weigh more than, right? It's going to be important, more than 20.4 ounces. So first thing I do is write down everything I know. I know the mean, I know the standard deviation, I know the value that they want me to look up, 20.4. The next thing you do is you calculate your z-score using your formula. So my x is 20.4. I'm going to subtract my mean, which is 20, and divide it by my standard deviation. And I get a z-score of 1.6. That means I am 1.6 standard deviations above the mean. So if you kind of visualize where you are on your chart, you're kind of pretty far to the right-hand side of the chart. They want to know how many are more than that. So again, like if you think about your chart, here would be your chart. This is your mean. If you're at 1.6, if this is 1 standard deviation and this is 2 standard deviations, you would be here at 1.6, somewhere right around there. They want to know how many are more than that, so they want to know this side of the curve. But if you remember, when you look this number up on your z-score table, it's going to give you this side of the curve because it always gives you the less than side of the curve. So when you look this number up, you're going to have to subtract it from 1. So when you look 1.6 up on your z-score table, you're going to get 0.9452. That will give you this purple side of the curve. But that's not the side you want. You want the greater than side, so you're going to have to subtract it from 1. So it'll tell you that 5.48% of the boxes weigh more than 20.4 ounces. Let's look at another one. Same exact criteria, except now they want to know that a probability that a randomly select box weighs at most 19.4 ounces. So once again, I hate to keep belaboring this point, but it's important to think about where you are on this curve, right? So if this here is going to be your average, which is 20 ounces, all right, and you want to know at most 19.4, then you want to know that's the greatest number, so you want to know what this side of the curve is. So I don't have to subtract it from 1 because that's going to be the biggest number is 19.4. So once again, write down what you know. Calculate your z-score. This tells you that you are minus 2.4 standard deviations away from the mean. It said at most, so we already figured that you want that left-hand side of the curve. So all you have to do is look that number up on your z-chart. You'll find it's 0.0082. If you convert it to a percentage, it'll be 0.82%. So 0.82% will weigh at most 19.4 ounces. Or another way to say it, 0.82% will weigh 19.4 ounces or less. Here's another example, same criteria. Now they want to know what percent will weigh between these two numbers. So once again, you have to write down what you know. I'm going to have to calculate this twice because I want an in-between. So I'm going to go to 19.4. I'm going to plug that into my z-score calculation, and I'm going to get a z-score of negative 2.4. So I'm negative 2.4 standard deviations away from the mean. If I go to my chart and look that up, that's 0.0082. I'm going to have to do the same calculation now for the other x value, which is 20.4. I get a z-score of 1.6. I look that up on my chart, I get 0.9452. Remember, you always subtract the percentages. So I'm going to take the 0.942 and I'm going to subtract the 0.0082. And it'll give me that 97.3% will be between those two amounts. So most of the boxes will be between 19.4 and 20.4 ounces.